Good day, my dear students. You're welcome back to class. In our previous lesson, we discussed number system and changing from one number base to the other. Well, today we shall be looking at the number system, but considering addition, subtraction, multiplication, and division of binary numbers. At the end of this lesson, you'll be able to do all of these operations in base 2 without difficulties. Introduction. When adding, subtracting, and multiplying in binary, the following identities holds. Addition. 0 plus 0 is equal to 0. 0 plus 1 is equal to 1. 1 plus 0 is equal to 1. And 1 plus 1 is equal to 10. Also, in multiplication, we have the following identities. 0 times 0 is equal to 0. 0 times 1 is equal to 0. 1 times 0 is equal to 0. And 1 times 1 is equal to 1. Let's take some examples to buttress our points. Example 1. Add 1011, 101, and 11101 in base 2, leaving your answer in base 2. Solution. If you do this addition, you are going to be having 101101 for your answer. But I want to analyze this in columns. Let's take the first column. 1 plus 1 plus 1 is equal to 11. And in binary, you put down 1, that's the last digit, and carry the other 1. Also, in the second column, we have 1 plus 1 plus 0 plus 0 equal to 10. What we need to do here is to put down the 0, which is the last digit, and carry 1. Then in the third column, we have 1 plus 0 plus 1 plus 1 equal to 11. Write down the 1, that is the last digit, and carry the other 1. Then the fourth column, we have 1 plus 1 plus 1, which is equal to 11. Also write down 1, which is the last digit, and carry the other 1. Then in the fifth column, we have 1 plus 1 equal to 10. Put down 0 and carry 1, giving us the answer that I mentioned earlier. Let's take another example. Example 2 says, do the following subtraction in base 2. And we have in A, 1110 minus 1001. Then in B, we have 10011 minus 111, leaving your answer in base 2. Solution. If you do the first one, that is 1110 minus 1001, your answer will be 101. And if you do the second one, you have 10011 minus 101, your answer will be 1110, all in base 2. But let's take the analysis of the columns. In the first one, that is A, in our first column, we have 1 from 0. That is, subtract 1 from 0, which won't go. So we move to the next column. And we have, in the second column, we have 10 minus 1, which is 1. Or if you do it in base 10, you will have 2 minus 1, which is also equal to 1. Then you write down that 1. You go to column 2. Then the one that has been removed to the first column, we leave that column 2 with 0. Now, if you say 0 minus 0, the answer is 0. So you just write down 0. Now, in the third column, we have 1 minus 0, which is 1. Just write down that 1. And in the fourth column, we have 1 minus 1 equal to 0. No need to write anything since it is 0. Therefore, the answer is 101. In other words, if you had put down the 0 in the fourth column, you have 0101. So it's better we just write 101 to base 2 for the answer. Then your B, first and second columns are clear, like your normal everyday arithmetic. But in the third column, we have this. We are going to be saying 100 in base 2 minus 1. Or you can do it the other way around using base 10. Then you say 4 minus 1 equal to 3. And your answer is 11 in base 2. So that gave us the answer for B. Let's take multiplication in example 3. It says multiply 1110 by 101 in base 2. Solution: 1110 times 101. If you multiply with 1, you will have 1110, because if 1 goes into 0, is 0, into 1, 1, into 1 again, 1, into 1, 1. Then if you multiply the top with 0, you will have all zeros. Then if you multiply again with 1, you have 0, 1, 1, 1. Then when you do your addition, considering it in binary, you will have 100110 for your final answer. I think it's clear, because multiplication is not that different from your addition. Example 4. Divide 10001 by 11 in base 2. Solution: before you can solve this problem, you must convert the numbers given in the question to base 10. And if you do so, you have the first number expanded as 1 times 2 raised to power 5 plus 0 times 2 raised to power 4 plus 0 times 2 raised to power 3 plus 0 times 2 raised to power 2 plus 0 times 2 raised to power 1 plus 0 times 2 raised to power 0. This will give us 1 times 32 plus 0 times 16 plus 0 times 8 plus 0 times 4 plus 0 times 2 plus 1 times 1. And this will give us 32 plus 0 plus 0 plus 0 plus 0 plus 1. If you add it up, you get 33 to base 10 for the answer. But that's not our final answer. So you also do same for the second value we are given in the question. 11 in base 2 converted to base 10 will give us, in terms of its expansion, as 1 times 2 raised to power 1 plus 1 times 2 raised to power 0. This will in turn give us 2 times 1 plus 1 times 1, which is equal to 3 in base 10. Therefore, we need to divide 33 by 3, all in base 10, before we get our final answer. When you do so, you get 33 divided by 3 as 11 in base 10. But we're asked to do our calculations in base 2. So we need to convert our 11 to base 2. And so we divide 11 by 2. We get 5 remainder 1. We divide 5 by 2. We get 2 remainder 1. We divide 2 by 2. We get 1 remainder 0. And if we divide 1 by 2, we get 0 remainder 1. So reading your answer from below, I mean the remainder part, you have 1011 as the answer for the question in example 4. Please, if you still have questions, you can make mention of them in your note and question box, and they will be attended to. Thanks.